Hello, my name is Gabrielle Castro, and this week we were assigned to complete an exercise which measured the resting and stimulated physiological responses of the cardiovascular, respiratory, and neuromuscular system. So I'm going to start with the resting. And for me, my resting breathing rate was about 7 to 8 breaths per minute, and my resting heart rate is about 55 beats per minute. Muscular contraction, obviously the relaxation occurs when there's no stimulation to the nerves. And our textbooks explains that when the iodine and calcium flow stops and troponin frees up to inhibit actin-myosin interaction, the recovery involves actively pumping that iodized calcium into the sarcoplasmic reticulum where it concentrates in lateral vessels. The calcium's retrieval from the troponin, tropomyosin protein complex, it turns off, activates site on actin's filament. This process serves two purposes. One is to prevent any mechanical link between myosin cross bridges and actin filaments, and then the other one is to inhibits myosin ATP's activity to curtail ATP splitting. This simply means that during the resting period, my actin and myosin filaments are in their original states and then my nerves are not stimulated. However, after completing the exercises, my muscles, my nerves, everything's obviously stimulated. So therefore, my breathing rate increased. That went to 15 to 16 breaths per minute. My heart rate increased, which increased to 20. I took this one twice. The first time it came out was 20 on the 10-second count and then 19 on the second time on the 10-second count, which translates to about 120 beats per minute. During this time or after the exercise, my muscles felt stimulated, but they felt elastic. And I was definitely short of breath and my heart was racing, but as I focused on controlling my breathing, I was able to relax. This helped me bring my heart rate down as well as my breathing rate. And I think this has a lot to do with my physical ability. I do train a lot, so my chronic adaptations or my body's ability over an extended period of times is higher than the average person. So, for example, the cardiovascular system over an extended period of time, the three adaptations are cardiac output increases. It increases during maximal exercise effort due to the increase of stroke volume, which is a result in greater oxygen supply, waste removal, and your endurance performance is going to be increased. Your blood pressure, your body's ability to normalize blood pressure. People with blood pressure in the normal ranges experience little change in blood pressure at rest or with exercise. However, hypertensive people find that their blood pressure is reduced towards normal as they do more exercise. This is due to the reduction in total peripheral resistance within the artery and improved conditions and elasticity of the smooth muscle in the blood vessel walls. Last one is your decrease in heart rate. As cardiac output at rest remains constant, the increase in stroke volume is accompanied by a decrease in heart rate. For the neuromuscular system, the slow twitch fiber behavior. As the duration of training lengthens, slow twitch fibers become increasingly dominant. In the book written by Colbert, Anarchy, and Lee, Anatomy and Physiology and Disease, an Interactive Journey of Health Professions, they explain that aerobic fitness and anaerobic fitness and muscular endurance training all improve the function of slow twitch fibers. Another one is muscles and livers increase their ability to store carbohydrates and fats, so it can be used for the ATP production, which is needed for muscle stimulation. Also, the number of capillaries of the muscle increase. This enables more oxygen to be delivered to your stimulated and working muscles. For the respiratory system, your lungs increase their ability to expand, enabling a greater quantity of air to move in and out. So your lung capacity increases, better performance. Another one is more capillaries are formed in the lungs over time allowing more blood to flow in and out, which improves the oxygen uptake. And then the last one, aerobic training improves the efficiency of the body's tissue at absorbing oxygen and removing the carbon dioxide.